So, this is a little bit harder, okay, because it deals with a little bit of X and Y. I'm going to still go through my reading protocol, so I'm going to read it once, okay? You need to buy some filing cabinets. You know that cabinet X costs $10 per unit, requires 6 square feet of floor space, and holds 8 cubic feet of files. Cabinet Y contains $20 per unit, requires 8 square feet of floor space, and holds 12 cubic feet of files. You have been given $140 for this purchase, though you don't have to spend that much. The office has room for no more than 72 square feet of cabinets. How many of which model should you buy in order to maximize storage volume? Okay. So, now I'm on step 2. I'm going to reread and identify what I'm trying to figure out. Alright, you need to buy some filing cabinets. You know the cabinet X costs $7. Okay, it requires 6 feet of floor space, holds 8 cubic feet. Cabinet Y contains 20 per unit, requires 8 square feet of floor space, and holds 12. All of those are statements. You have been given $140 for this purchase, so you don't have to spend that much. The office has room for no more than 72 square feet of cabinets. Okay, those are all statements. How many of which model should you buy in order to maximize volume storage? All right, that is my question. Okay, and that is what I'm trying to figure out. How many of which model? Of which model? Okay, model? What the heck are they talking about with models? Well, they're talking about 2 things here. They're talking about cabinet X and cabinet Y. They pretty much already gave you the what X and Y are. So, I'm going to define my variables right now. How many of which? Cabinet X, that's going to be stand for my X. And cabinet Y, that is my Y. Alright? So those are of which model. Those are the 2 things that they're talking about. Second thing is identifying words or phrases, and you can you might know all these words. Again, this is an individual thing. Just know to ask. Okay? You might, okay, not know the units. Okay? The square feet, the cubic feet. What the heck is that? You gotta ask. Okay? So that's what we're talking about with the vocab. Identify phrases. Okay? Now, identify the important information you need to be aware of. So I'm going to start crossing stuff out now. Now that I've read it twice, now I know what's important. And I know what the question is asking about. That's the biggest thing. Before I cross something out, I need to figure out what the question is asking. Okay? So, you need to buy some filing cabinets. Statement, I don't care. You know that. Okay? You know that? Okay, you're telling me in a second. I'm going to cross that out. That's useless information. Okay? Cabinet X costs $10 per unit, requires 6 square feet of floor space, and holds 8 cubic feet of files. Those are all numbers. They might not look like it because they're written out, but those are all numbers in units that you need. Okay? Cabinet Y costs $20 per unit, requires 8 square feet of floor space, and holds 12 cubic feet of files. Important, okay? You have been given $140 for this purchase, okay? Do you care if it's for this purchase? I don't care. I've been given $140. That's how much I can spend, okay? Though you don't have to spend that much. I don't care. If someone gives me money, I'm going to spend it all. All right. The office has no more than 72 square feet of cabinets. I don't care where it is. I don't care where if it's in the office. Okay? It just cares that it's no more than 72 square feet of cabinets. Okay? And then this entire question is important. Okay? Now, okay, I'm going to reread the reduced math problem. Cabinet X costs $10 per unit, 6 square feet of floor space, and holds 8 cubic feet. Cabinet Y costs $20 per unit, requires 8 square feet of floor space, and holds 12 cubic feet of files. you've been given $140. No more than 72 square feet of cabinets. How many of which models should you buy in order to maximize storage volume? All right. So, the other thing that you might have noticed, okay, is also what is underlined, okay? Because there's also very important stuff here to maximize storage volume, okay? That is also part of the question, okay? So you need to definitely highlight on that, all right? So that maximizing storage volume puts it into the linear optimization problem, okay? So the linear optimization is always to maximize. That's your key word. That is what's going to tell you what type of problem it is, okay? Now I'm going to solve the problem. So I'm going to go through my steps. I've defined my variables. I'm going to start writing my inequalities. Well, the reason why I chose this problem is it had a lot of units in it, okay? And you might remember me talking to you individually about a money equation, a total equation, that sort of thing, okay? Those are all units that have to put together. So I identify all my money, all my units that need to go together. So my money is X costs $10, Y costs $20, and I have 140. Those are all my dollars. So I'm going to create an equation that says 10x plus 20y can't go over. It has to be less than or equal to 140. That's my money equation. All the other money. Okay? So now I get rid of the money. I don't really care about the money. Okay? Now there's another unit in there, 2, comma, requires 6 square feet. Square feet is a unit. Square feet is a unit. And each of them have it. Square feet and then 72 square feet. Okay? Those key you in onto what goes into each equation. Okay? So, 6 square feet of floor space. So, 6x plus 8y, no more than 72. So that has to be less than or equal to 72. All right. So now I'm done with my square feet. All right. Now I go into my third number that I have. Okay. And it holds 8 cubic feet. 8 cubic feet. Unit goes with something. 12 cubic feet goes with the other cubic feet. Oh shoot. Is there any other number that deals with cubic feet? Well, it's kind of slick how they did it. And you might need to remember back to geometry. Cubic feet is another way of saying volume. Anytime you're dealing with cubic something, it's a volume. And guess what? Those cubic feet, we're trying to maximize it. So you know that profit and cost equation? That is coming from my cubic feet. So my profit, okay, or my cost equation, my thing that I'm trying to maximize, okay, the f of xy is going to end up being 8x, because that's how many cubic feet cabinet X holds, plus 12y. That's what I'm trying to maximize, okay? And it will tell you right there. And it was kind of slick how they did it, because they asked for volume. So now I have these two things. There's actually a couple more, right? I'm still going to buy some cabinets over here. Yeah, so I'm not going to buy negative stuff, okay? So x has to be greater than or equal to 0. Y has to be greater than or equal to 0. Means that we're somewhere in this area right here, okay? So now I'm just going to graph these, okay? So I have to solve for y, okay? In this equation, I'm going to solve for y, and it's going to be y is going to be less than or equal to negative 1/2 x plus 7. Okay? I would subtract the 10, divide by 20. Okay? So I'm just going to graph that. Boom. Go down 1 over 2. Nope. Every one of these is half. Okay? So I'm going to go down 1 over 2. Okay? Down 1 over 2. Down 1 over 2. Down 1 over 2. Down 1 over 2. So that is my first equation, and it's less than, so it's shaded below. Second equation is going to come out to be y is going to be less than or equal to negative 3/4 x plus 9. Okay? Subtract 6, divide by 8, and I'm going to get this. Okay? 9. I'm going to go down 3. 1, 2, 3. Over 4. 1, 2, 3, 4. Down 3. 1, 2, 3. 1, 2, 3, 4. Down 1, 2, 3. 1, 2, 3. Okay, so it's off. Alright. And then I'm going to figure out this is all my shaded region. Okay? So 1, 2, 3 over 1, 2, 3, 4. So my final equation is going to be at 12, 0. And it ran off. I apologize for that. So now I identify my vertices. Okay? 12, 0 is 1. Okay? 8, 3 is another. Okay? 0, 7. And, okay, because I'm shading in here, sometimes it's the best to produce nothing. Alright? So now I'm going to take those vertices, and I'm going to plug it into my maximizing function. Okay? So, the first one is easy. 0, 0. That's going to go to 8 times 0 plus 12 times 0, which is 0. Boom! Didn't spend anything, didn't buy anything. Second equation, 0, 7. 8 times 0 plus 12 times 0. No, 12 times 7. That's going to be 84. Okay? 84. Okay? Second equation is going to be 8, 3. 8 times 8 plus 12 times 3. Grand total of 64 plus 36. And 12, 0. Times 12. 96. Okay, so I plug that in. Now, what I want to do, how many of which should to maximize my volume storage. Maximize my volume storage. Good. That's my max value, right? So I should buy 8 cabinet X's and 3 cabinet X. Because that is my storage. I'll get 100 cubic feet of storage if I have that. Because remember, my maximizing function is in volume. It's not money. I'm trying to maximize volume. And you might have saw that I did make that mistake. But I'm actually asking about cubic feet. That's what I want. So that's my cubic feet right there. Okay? That will maximize my volume. cubic feet. Okay? So that is linear programming. It is a lot to take in. That's why this video is so long. So what I want you guys to try is this one. It's a tier 1, graph these and then plug it in. And this word problem here. Now what I've done here is I've given you the graph, okay? And each one of these bullets is going to set up an inequality for you for a little practice. Please come in with me and check in with me at any point.